Up to this point, we have derived geometry from structural necessity. Coherence above threshold produces stabilization. Directional variation produces metric structure. Non-uniform variation produces curvature. Redistribution of coherence produces geometric evolution. In the previous episode, we tightened the constraints on that evolution: conservation under closure, local propagation, continuity, reciprocity between coherence and curvature, coordinate independence, dimensional compatibility. We now ask a direct question: do these constraints resemble the structural form of gravitation? Not numerically, not symbolically, structurally. In general relativity, gravity is not treated as a force. It is treated as curvature of spacetime. Matter and energy influence curvature. Curvature influences motion. This mutual coupling is the heart of gravitational theory. Now compare that structure to what we have derived. Coherence density influences curvature. Curvature influences coherence redistribution. Geometry evolves dynamically. That is the same pattern of mutual coupling. But the origin is different. In conventional theory, space-time is assumed as fundamental. In this framework, space-time is an encoding of coherence distribution. The resemblance is not inserted. It arises from structural constraint. Now, consider conservation. In general relativity, conservation of energy and momentum is built into the structure of the field equations. In our derivation, conservation of coherence under closure is required for stabilization. Both frameworks enforce conservation at the geometric level. Now, consider covariance. In relativity, the governing equations are independent of coordinate choice. In our framework, evolution rules must depend only on structural relations, not labeling of stabilized elements. This imposes coordinate independence, again structural alignment. Now consider propagation. In relativity, changes in curvature propagate at finite speed. In our framework, coherence redistribution must propagate locally and continuously. Instantaneous global restructuring is forbidden. Again, structural alignment. Now consider equilibrium. In relativity, absence of energy leads to flat spacetime. In our framework, uniform coherence leads to flat geometry. Flatness corresponds to balance. Curvature corresponds to imbalance. The pattern repeats. Now consider geodesics. In general relativity, objects follow geodesics determined by curvature. Motion is not forced. It is guided by geometry. In our derivation, stabilized identities navigate coherence gradients through paths of minimal structural distortion. Trajectory arises from geometric encoding of coherence variation. Motion emerges from structure, not force. Again, alignment. But now we must be careful. Alignment does not mean identity. We have not introduced numerical constants. We have not specified exact proportionality. We have not derived precise quantitative relations. What we have shown is structural compatibility. The architecture of gravitation fits inside the corridor defined by coherence dynamics. That matters. Because if gravitational structure falls inside that corridor, it may not be arbitrary. It may be the simplest solution satisfying stabilization constraints. Now, consider dimensionality. General relativity operates in 4 dimensions. Earlier, dimension emerged from minimal generating basis. If that basis produces 4 independent directions of coherence variation at large scale, then 4-dimensional geometry is not assumed. It is selected. If stabilization favors a specific minimal basis size for global coherence, then observed dimensionality may be structurally preferred. Again, we are not asserting. We are identifying compatibility. Now consider gravitational waves. In relativity, disturbances in curvature propagate as waves. In our framework, disturbances in coherence redistribute through feedback with geometry. Curvature fluctuations emerge as coherence oscillations. Wave-like propagation becomes inevitable. Once more, structural resemblance. Now, consider something deeper. In relativity, the field equations relate curvature to energy density. In our derivation, curvature relates to coherence density. If coherence density corresponds to what we observe as energy density, then the two pictures may converge. But that requires careful interpretation. We cannot equate them casually. We must show mapping. That belongs to later analysis. For now, the key observation is this. The structural form of gravitational dynamics appears not as an independent invention, but as the minimal evolution rule compatible with coherence stabilization. If that is correct, gravity is not fundamental, it is emergent. Not emergent in the loose sense of complexity. Emergent as a necessary projection of coherence, redistribution under threshold constraint. Now, pause. Why does this matter? Because it changes the interpretation of space-time. Instead of asking why matter curves space-time, we ask, why does coherence redistribution produce curvature patterns that resemble gravitation? Instead of asking what gravity is made of, we ask, what structural constraint forces gravitational form to appear? This shifts the question from ontology to inevitability. Now consider possible deviations. If coherence dynamics deviates slightly from the simplest structural form, small corrections to gravitational behavior would appear. At very high coherence density or very small scale, geometric response may differ from classical prediction. This opens the possibility of observable signatures, which means this framework is not metaphysical. It is testable. But testability requires caution. We must first derive the precise evolution rule from structural constraints. We are not there yet. Today, we have established structural alignment, not identity. Alignment. That is enough for this stage. Now step back across the entire arc. Difference produced refinement. Refinement produced stabilization. Stabilization produced threshold. Threshold produced metric. Metric variation produced curvature. Coherence, redistribution produced dynamic geometry. Structural constraints narrowed evolution rules. Those rules align with gravitational architecture. We did not begin with gravity. We ended up at its doorstep. That is the significance. In the next episode, we ask the most delicate question yet. If gravitational structure is the minimal coherence evolution rule, what determines the strength of the coupling? Why does curvature respond with the magnitude we observe? Where does the scale enter? Because structure alone does not yet fix constants. That is the next threshold, and it may reveal whether this framework is merely compatible with physics or explanatory.